video, you can explain the buoyant force exerted by air and liquid. Apply Archimedes and Bernoulli's principle in sea and air transport. Why this overloaded boat does not sink? How can a metallic vessel be less dense than water? How can an object be either sink or float in the water? Why the wood floats and a metal sinks in a liquid?
The train it wouldn't stop at my station. Home alone, that was my consignment. Solitary confinement. So when we met, I was getting around you. I didn't know I was looking for love until I found you.
How can a rubber ball float in spite of its big size, while a marble, coin, and a needle are submerged in the water? In the second part of this video, we will explain how do birds fly, and how can a huge airplane manage to stay up in the air. These are just simple questions that Archimedes and Bernoulli will explain with their simple but meaningful science principles.
And now the planets circle around you. I didn't know I was looking for love until I found you.
One interesting manifestation of forces exerted by fluids is the floating of objects in water. Some objects float and some sink. Some objects can be partially or wholly submerged when placed in a liquid. But what makes them float or sink in the water?
In a world where tears are consolation.
All objects exert a downward force due to their weight. On the other hand, water exerts an opposite upward force. We call this the buoyant force. A wide wooden object floats on the water, while a smaller, hence lighter piece of metal sinks. You may say that the wooden object is less dense than water, so it floats, whereas the stone or metal ball, though smaller, is denser, hence it sinks. The wood is partially floats in the water, though it has a greater mass than the metal. When an object is immersed in a given liquid, it displaces a volume of that liquid equal to its submerged volume. At the same time, the object is pushed up by a force equal to the weight of the displaced liquid. We can measure the weight of the load using a spring balance by hanging it into the air. But when it is immersed in the water, the reading decreases. The decrease in the spring balance reading is equal to the buoyant force exerted by the water upward. The buoyant force is equal to the weight of the load and weight of the displaced water. Since weight is equal to the mass times the gravitational constant, then buoyant force is equal to the mass times gravity. In the equation, density equals to the mass divided volume. Mass is equal to the density times volume. By substitution, buoyant force is equal to the volume of the displaced liquid, density, and the gravity. The buoyant force on the body equals the weight of the displaced liquid. A body partially or wholly submerged in the liquid displaces the volume of liquid. The volume of liquid displaced is equal to the volume of the submerged portion. We call this the Archimedes principle. This is the reason why a metal vessel floats or partially submerged in the water, even it is denser than the water. A boat or ship is built considering Archimedes' principle. In order to float, a boat must displace an amount of water whose weight is at least equal to its total weight, including cargo and the passengers. Since the weight of water displaced by a boat is equal to the buoyant force, then the buoyant force is equal to the weight of the boat. A huge ocean liner or tanker made of iron should logically be denser or heavier than an equal volume of water. The very fact that such a vessel floats in water means that it is less dense than an equal volume of water. The working principle how an airplane flies and a boat moves is somewhat similar. They both powered by an engine. The boat floats in the water because of buoyancy. It is buoyancy also why an airplane flies. These systems follow the law of conservation of energy. Since no outside force acts on them, it must have a constant energy. The total kinetic energy and the potential energy at any point within the liquid must be constant. If the boat is at rest, buoyant force acts on it, which is equal to the weight of the boat. If an airplane is at rest, the resultant forces acts on it is zero. The weight of an airplane stops it from flying. But if it overcomes the air resistance by increasing the lift force, it will start to take off. The shape and structure of an airplane and boat are designed to increase the speed so as to overcome the air and liquid pressure. This phenomenon is called Bernoulli's principle. Bernoulli recognized a rare situation where a physical fact runs counter to an intuitive concept. You may think that when fluids pass through a narrow opening, the pressure increases because the speed of flow increases. Experiments have shown results opposite to this intuitive concept. Since a liquid is not compressible, just to change its volume, a small amount would require tremendous pressure. This means that work has to be done on the liquid, increasing the potential energy of its molecules. A liquid under pressure, therefore, has potential energy, and if it flows, it must also possess kinetic energy.
Didn't know I was looking for love until I found you, baby.
One other situation to explain Bernoulli's principle is how the paper tent reacts if you blow the inner part faster. Greater speed is necessary to decrease the pressure inside. Thus, the two sides of the paper tent will move closer together. Buoyancy in air is best explained by the balloon. The gas inside the balloon is less denser than the surrounding gas. Less dense gas gives a lesser pressure, so the balloon will float in the air. A while ago, we've asked some questions that even a young boy wonder. How do birds fly? The wings of the birds are curved to lessen the air resistance at the top and increase the lift force at the bottom. Engineers that design airplane follows the structure of the wings of the birds. This make the birds stay up in the air. How can they manage the air resistance? We must learn from the bird the values of unity. They form a group to work as a team with the leader. The leader experiences the air pressure most than the birds at its back, but later they change position to support their weakening